From NASA's Kennedy Space Center in Florida, you're watching live coverage of the 13th Spacex cargo resupply mission to the International Space Station. Hi, I'm Stephanie Martin, and thanks for joining us. Today's launch to the station is scheduled for 10:36 a.m. Eastern from Space Launch Complex 40 on Cape Canaveral Air Force Station. Coming up, you'll hear about the exciting research heading to the station and get a sneak peek on the events happening here at Kennedy Space Center in 2018. Today's launch will be the first of the year from Pad 40. The Dragon spacecraft and Falcon 9 rocket at the launch pad both previously flew on cargo resupply missions for NASA. At the time of launch, the space station will be flying 258 miles above northern Oman at the southeast tip of the Saudi Peninsula. The Cargo Dragon spacecraft will deliver about 4,800 pounds of science, research, crew supplies, and hardware to the orbiting laboratory. Today's launch has an instantaneous window, which means SpaceX has a single second to launch. About 10 minutes after launch, Dragon reaches its preliminary orbit. It will then deploy its solar arrays and begin a series of thruster firings as it heads to the space station for its targeted arrival on Sunday, December 17th. We're about 34 minutes from today's launch. NASA's Joshua Finch and Mike Curie are monitoring SpaceX's countdown activities in the control center. Guys, how are things progressing for today's launch?
Hey, thank you very much, Stephanie. Good morning, Josh.
Good morning, Mike. Things are progressing toward liftoff of the SpaceX Falcon 9 rocket. Everything's from our position is going well at the moment. Today's will be the first launch from Space Launch Complex 40 since 2016. Mike, can you tell us more?
Yeah, in a recent interview on Pad Status, SpaceX said that they looked at this not only as an opportunity to rebuild the pad after they had an anomaly, but also to modernize it and make it high-tech. The pad, originally built in the 1960s for the Titan rocket fleet, was leased by SpaceX in 2007. The company then made initial upgrades to Space Launch Complex 40 to accommodate the Falcon 9 rocket.
The recent upgrades started with stripping the pad down and adding reinforcements to streamline operations. Some of the pad enhancements include a new transporter erector, augmenting the water systems to add a water-cooled flame diverter, and upgrading the liquid oxygen system.
And with the completion of this pad, SpaceX now has the capability to launch from two locations on Florida's Space Coast. Launch Complex 39A at Kennedy Space Center and here at Cape Canaveral Air Force Station Space Launch Complex 40.
The countdown has progressed per the timeline. The milestones already performed include collision avoidance coordination with the Eastern Range, a checkout of the Flight Autonomous Termination System, loading of RP-1 began as planned. The Eastern Range confirms it is go for the launch and landing of the Falcon 9 first stage at Cape Canaveral Air Force Station Landing Zone 1, and the loading of liquid oxygen began at T-minus 35 minutes at 10:01 a.m.
And weather today does not appear to be a concern for us. U.S. Air Force 45th Weather Squadron Officer Lieutenant David Myers, our launch weather officer today, briefed the team earlier and says that we can expect winds 9 to 12 miles an hour from the south-southwest, temperature 67 degrees at the time of launch. The only concern that he mentioned was the thick cloud rule, which does not appear to be a concern, even though officially the forecast still says 10% probability of violation. He briefed the team that he is expecting no launch commit criteria violations this morning, so that's good news. And for now, that is our status from Falcon Launch Control. And Stephanie, we will hand it back to you.
Thanks, guys. SpaceX will deliver more than 4,800 pounds of supplies and payloads, including critical materials to support dozens of the more than 250 science and research investigations that will occur during Expeditions 54 and 55. The approximately 26-foot-tall Dragon trunk will carry about 1,400 pounds of unpressurized cargo to the station, which means the cargo inside the trunk will be exposed to the vacuum of space, unlike the experiments inside the Dragon that are pressurized with air to simulate the atmosphere. The Dragon spacecraft will spend approximately 1 month attached to the space station, and then will return to Earth filled with 3,600 pounds of research, hardware, and crew supplies. Research conducted aboard the International Space Station helps advance scientific knowledge in Earth, space, physical, and biological sciences for the benefit of people living on our home planet. It also serves as the world's leading laboratory where cutting-edge research and technology development is pushing us further toward human deep space exploration missions back to the moon and onto Mars. Our Amanda Griffin recently learned more about an investigation that could help scientists better treat patients with osteoporosis and heal broken bones.
I'm here with Brian Hess, the founder and CEO of Launchpad Medical. Brian, I understand you're working on a new bone material that we're sending to space. Can you tell us a little bit about how what you're working on is different than what's currently on the market?
Sure. What's currently on the market are bone grafts, and these materials are non-load bearing. They don't have much structural strength, despite being able to regenerate new bone. Our material is actually a bone adhesive, so it's injectable, and when placed in the body, it can actually glue broken bones back together. We get immediate and very strong load-bearing strength when we actually test our material.
So why are we sending this to space?
So what we want to do is we ultimately want to treat patients with poor quality bone. And in space, it's in microgravity, and astronauts are losing up to 2% of their bone mass per month. So it creates a really nice environment to actually test our material. And if we can show that new bone can grow in the presence of our material in space, it potentially could have huge value for us here on Earth for patients with, say, osteoporosis.
Right. Can you tell us a little bit about how your experiment's going to work?
Sure. Our experiment will look at how well new bone grows up in space in the microgravity conditions, but we'll actually compare it to wells which do not have our material as a control, but also to other materials that are currently on the market to see how well we compare to them as a benchmark.
How much growth are we expecting?
What we're generally looking at are the cells and actually how active they are and if they differentiate and proliferate in the presence of our material. And then the biologists back on Earth, they'll be collecting samples of the media and they'll be looking at what's actually produced by these cells. The experiment will be about 14 days, and then we'll do the post-analysis after it returns to Earth.
Excellent.
Thank you.
Back to you, Stephanie.
Thanks. Now that you know a little bit more about the research launching on today's mission, let's review a few quick facts about today's launch vehicle. The Falcon 9 is a two-stage-to-orbit rocket. It uses liquid oxygen, often referred to as LOX, and rocket-grade kerosene, known as RP-1, for its propellants. The Falcon 9 has 9 Merlin engines on the first stage and a single Merlin engine on the second stage to deliver a payload, in this case, the Cargo Dragon spacecraft, to the desired orbit. The SpaceX Falcon 9 rocket at the pad previously flew on the company's 11th cargo resupply mission to the station, and the Cargo Dragon is the same spacecraft that flew on the company's 6th resupply mission. Today, the Cargo Dragon is the only spacecraft that can return scientific research from the space station to the Earth. NASA's Amanda Griffin was able to sit down recently with Jan Clausen from Made in Space to learn more about a piece of hardware launching on today's mission.
Hi, I'm here with Jan from Made in Space, who's looking to revolutionize the fiber optics industry with space-enabled technology. So Jan, tell us a little bit about the experiment you have going up.
So the experiment is to process an exotic material known as Z-bland into fiber optic cable. The purpose being, in 1G, Z-bland creates little crystals inside of it that kind of ruins its performance as a long-range communications fiber. In 0G, the hope is that those crystals are diminished significantly so that then we can use it for, big, long cables to be used for the internet and all sorts of telecommunications roles.
So what exactly is Z-bland and how is that different from what's currently being used in fiber optic cables?
So current fiber optic cables are in general made of silica. Z-bland is a special material that's made of a whole bunch of different elements that is just more stable, the theory goes, in 0G.
Okay, so you say it's more stable in 0G, and then you're going to bring that down to Earth. And then what will you hope to happens to it when you implement it here on Earth with the new Z-bland?
Well, when we get it down to Earth, we'll take it for study, and we're hoping to see that the attenuation is a lot less than silica fibers. And the attenuation is how much light is lost when you shine a light through the fiber optic cable.
So for the average Joe, what would that mean to them?
So that'll mean, ideally, that we can replace current fiber optic cable with Z-bland cable. And that would result in shorter communications times, less delay in communications, more bandwidth for companies to play with, and hopefully overall a increase in the amount of fiber optic cable for your internet.
So you're trying to make life better here on Earth?
Yes.
That's excellent. And how long will you be up there making this?
The current plan in our prototype experiment is for a month. We'll manufacture hopefully 1,500 meters of fiber and bring it down and study it. And then hopefully use the results of that experiment to kind of fine-tune our process and then eventually create a commercial unit that can process kilometers of fiber. The ultimate goal is ultimately to produce hundreds of kilometers of fiber that we can then bring back to Earth and sell to the consumer.
Thanks so much and good luck with your experiment.
Thank you very much.
Back to you, Stephanie.
At T-minus 25 minutes and counting, let's go back to the Control Center for an update of today's launch.
Thank you, Stephanie. As you've been hearing, today's launch of Spacex CRS-13 is a collaborative effort of scientists, but that's not all. Mike, can you tell us more?
Yeah, the 3 members of the International Space Station, Josh, are awaiting the arrival of Dragon on Sunday, and teams here on Earth are working hard today to make that special delivery to them. Adjacent to NASA's Kennedy Space Center at Cape Canaveral Air Force Station, the SpaceX Launch Control Center team is working with its partners, as you see here, at SpaceX Mission Control in Hawthorne, California. And meanwhile, in Houston, Texas, at the International Space Station Mission Control Center, teams are overseeing today's launch and awaiting the launch of Dragon and Falcon, as the spacecraft then would head toward the International Space Station for arrival on Sunday. So as you can see, it is a total team effort spanning the U.S. from the east to the west coast. And at T-minus 25 minutes and counting, we'll send things back to Stephanie Martin now, and we'll keep our ears on the loops here and let you know how things are going, Stephanie.
Thank you, guys. SpaceX CRS-13 is an example of NASA's work with the American private sector to infuse innovation, advance technologies, and accomplish the nation's goal of human missions back to the moon, onto Mars, and beyond. NASA partnered with Orbital ATK and SpaceX under the first commercial resupply services contract to deliver cargo to the station. This approach provided a technical and financial boost to the U.S. industry to develop commercial space transportation capabilities. In this approach, NASA serves as a long-term customer, providing a market base for commercial launch services. In 2016, NASA selected Sierra Nevada Corporation's Dream Chaser spacecraft to serve as an additional cargo-carrying spacecraft. NASA has worked with the company on the Dream Chaser since 2010 as part of the agency's Commercial Crew Initiative to aid in the development and demonstration of safe, reliable, and cost-effective crew transportation capabilities. As you can see, they recently completed an approach and landing test over Edwards Air Force Base, which proved the spacecraft's atmospheric flight performance along with its return and landing capability. The Dream Chaser will begin delivering cargo to the International Space Station in 2019. These partnerships not only help NASA by providing access to the space station and allowing the agency to focus its resources on exploring beyond low Earth orbit, they also help our nation by strengthening the industrial base, developing a new high-tech industry, and expanding our economy. You've already heard about human health and fiber optic technology research. Another interesting experiment launching on today's mission will study how the Earth uses energy from the sun. This will help scientists better understand how our planet is evolving. Let's learn more.
Let's say this is the equivalent of the sun's total energy output. You can accumulate $100 a lot of different ways, but $100 is $100. If energy from the sun were $100, it would be important to know what kinds of currency was coming in: big groups of pennies, whole dollar bills, or combinations. The total amount of solar energy falling on Earth generally doesn't vary more than about $1 to $100, but the kinds of energy from the sun can fluctuate. Remember that light we see with our eyes is actually a combination of many different colors or wavelengths. That's true also for the light we do not see. The composition of that light matters to understanding Earth's energy budget, and that's the reason NASA has a new instrument designed to study this question. It's called TSIS, the Total and Spectral Solar Irradiance Sensor.
It is important to know that the sun supplies virtually all of the energy coming to Earth. But in between the Earth and the sun, there is the atmosphere. And in the atmosphere, there are clouds, there are aerosols, that is particles, there are gases that interfere with the solar radiation reaching Earth. So that's why we need to fly a satellite to be above the atmosphere.
Mounted to the International Space Station, TSIS will collect detailed assessments of solar energy. Those data will be vital for scientists to make more accurate forecasts about climate change and other interactions between our planet and our parent star.
One of the risks with human spaceflight is the debris in low Earth orbit. Launching on today's mission is a piece of hardware that will measure the debris around the space station. NASA's Amanda Griffin has more.
I'm here with Joe Hamilton, and we're talking space debris. Joe, can you tell us in space around the ISS, like how much debris hits the space station on any given day?
Well, we don't know exactly. We have estimates of what the environment looks like, and there's no sensors that tell us when the space station is actually impacted by small debris.
And that's where you guys come in with your new space debris sensor, right?
Right.
Okay, can you tell us a little bit about that? Like, where's the space debris coming from first, and then how are you going to record that?
So the debris we'll be measuring comes from human activities in space.
Okay.
And we're going to be using multiple layers and multiple techniques to try to measure not just that the sensor is impacted, but how large the object is, what direction the impact came from, how fast it was going. And by measuring the energy of the collision, we also hope to be able to estimate the density of the object.
Okay, so you're measuring a lot of points there. So you mentioned how large the objects were. How small of objects can you measure with this sensor?
Well, the sensor should be able to pick up a tiny piece of, just a tiny grain of sand.
Why do we care about a tiny grain of sand in space?
Well, even something small can cause some damage when it collides at high velocity. It might hit, say, a handrail and cause a sharp edge that...
Oh, and then if an astronaut's glove runs against it.
Exactly.
Okay, so yeah. So that's important work that you're doing. So I understand your sensor will be on the space station for 2 years. What will your team do with all that data that you collect?
Well, the data that we collect will be used to gather statistics, and those statistics are used in the engineering model to update the environment estimates of how much debris is in each of the orbits in low Earth orbit.
And ultimately to help inform future spacecraft design, I assume?
Yes.
Excellent. Well, good luck with launch today, and we look forward to seeing what comes out of your data and how that can help us, delve further into the universe.
Thank you.
Thanks for being with us. Back to you, Stephanie.
The Center for the Advancement of Science in Space, known as CASIS, is the organization that manages and oversees research on the International Space Station U.S. National Laboratory. Recently, CASIS unveiled its latest mission patch, designed by Lucasfilm. It represents all of the payloads intended for the National Laboratory in 2017 and features characters and spaceships from the Star Wars franchise.
Growing up, I was always a huge fan of science and space, and if I wasn't in the film business designing for movies, I would hopefully be working for NASA.
There is a long, pronounced history with mission patches, both from the aviation industry as well as the aeronautics industry. Traditionally, for NASA-related patches, the astronauts themselves have been designing those patches for years. But at the ISS National Laboratory, we try to collaborate with unique partners to help develop these patches that are representative of all ISS National Lab research during a given calendar year. And who better to collaborate with than Lucasfilm?
In designing the patch, I had to bring in the best designers that I could think of, and that's Kelly and Stacy of Everly Design.
He asked us, hey, would you guys be interested in working on this project? And our eyes were just like, yes.
I actually first worked with them on early designs of the Rogue One title. It was a great opportunity for the three of us to work together again. The first step was to figure out, okay, what are the iconic moments or imagery that we want to merge with the space station?
In particular, there was this one scene on Tatooine. They have that beautiful sunset. We took elements of that and derived our colors for the final piece.
Doug's creative vision was to try to include some of the droids that have been involved in the Star Wars franchise in this mission patch.
And so the obvious choice was, okay, let's design it around the new robots like BB-8 and Chopper and K2.
And that is also very symbiotic of the ISS, because the ISS is all about enhancing technology.
That captured everything about the space program for me. It talked about the future, talked about the adventure, the longing for the adventure.
Our job as graphic designers is to simplify things, and in this challenge we had to take something that is an entire Star Wars universe and then also the world and blend those two worlds together.
The final design encompassed the Millennium Falcon, the Death Star and these droids. The droids look out into this vast space of discovery and exploration. We felt like that created a wonderment that we can relate to by looking out at the stars.
The final design of the patch, I think, is a perfect culmination of everything that we're trying to achieve.
This mission patch with Lucasfilm, it really helps to represent a banner year for CASIS and the ISS National Lab as a whole in 2017. We've already had well over 100 experiments launched to the ISS National Lab, representing a myriad of scientific disciplines, from life sciences, Earth observation, remote sensing, material sciences, physical sciences, technology development, STEM and STEAM education. The ISS National Lab is truly a platform for innovation, and to be able to have this collaboration with such a recognizable brand is going to bring that research to the forefront even more so.
As 2017 closes out, we wanted to share the many exciting things that you'll see next year. NASA's Launch Services program is scheduled to launch 6 missions in 2018. Our Joshua Santora sat down with Tim Dunn, one of NASA's launch directors.
So Tim, thanks for having me out today. We're here in one of the launch vehicle data centers, one of several that are used by the Launch Services program. And these rooms are going to be really busy this coming year.
2018 for Launch Services program is going to be an exceptional year. We have 6 missions scheduled. We're going to be flying on 5 different rockets from 6 different locations in 2018.
6 missions, that's an exciting year. So what's really got you excited?
Yeah, I've got 3 of the missions, and my partner Omar Baez, our other program launch director, has the other 3. For me, it's going to be the GOES-S mission in March. GOES-S, weather satellite at geostationary orbit. It gives us that big picture of weather. Our nation experienced last fall all the hurricanes. Yeah. We were able to use the weather data from GOES-S's predecessor, GOES-R, which was launched just over a year ago. And we got very precise data on those hurricanes. So I'm very excited to add another spacecraft to that constellation, the next generation of GOES satellites, coming up on March 1st. One of our other missions next year is a mission called InSight, and that is a probe that is heading to Mars. What's unique about it is we're going to launch, for the very first time in our nation, we're going to launch a mission on an interplanetary trajectory from the west coast of our country, launching from Vandenberg Air Force Base.
Very cool. So breaking new ground there. That's awesome.
Absolutely.
I've been told that the Delta II is one of your personal favorite rockets. Number 1, is that true? And number 2, this is actually a pretty important year for the Delta II. Can you talk about that a little bit?
So, as a parent of many rockets, we're not supposed to have favorites, but Delta II does hold a special place in my heart. It's called ISAT-2 is the mission. It will be the final Delta II launch. We're really looking forward to that final opportunity to show off that rocket's capabilities. ISAT-2 is a special mission. It's going to go into polar orbit. It's going to study our ice caps at both poles, provide us a lot of polar surface topography data. The mission is exciting. The rocket is really thrilling to launch, and it's one of the children, but I do love them all.
Well, Tim, you're a part of an amazing team. Good luck to you guys in 2018. It's going to be an awesome year. Thanks so much for having me out.
Oh, you're welcome. Thank you for coming out.
NASA's Commercial Crew Program is working with Boeing and SpaceX to launch our astronauts to the International Space Station from right here along Florida's Space Coast. Both companies are targeting flight tests with their spacecraft systems to the International Space Station in 2018. the addition of Boeing's CST-100 Starliner and SpaceX's Crew Dragon to the manifest of spacecraft heading to the station offers more than just opportunities for astronauts to fly aboard American spacecraft. It also could increase the amount of science and broaden the research that can be performed aboard the orbiting laboratory. That's because the new generation of human-rated spacecraft are designed to carry time-critical research to and from the International Space Station along with their astronauts. President Donald Trump is sending astronauts back to the moon. The president signed a space policy Monday directing the U.S. to lead an integrated approach to send humans back to the moon, followed by missions to Mars and beyond. NASA will lead the innovative and sustainable program of exploration with commercial and international partners to enable human exploration across the solar system and bring back to Earth new knowledge and opportunities. We would like to welcome those of you just joining us on Facebook Live. The SpaceX Falcon 9 and Dragon spacecraft are poised to lift off at 10:36 a.m. Eastern from Space Launch Complex 40. The Cargo Dragon spacecraft will deliver about 4,800 pounds of science, research, crew supplies, and hardware to the station. Today's launch has an instantaneous window, which means SpaceX only has 1 second to launch. About 10 minutes after launch, Dragon will reach its preliminary orbit. It will then deploy its solar arrays and begin a series of thruster firings as it heads to the space station for a targeted arrival on Sunday, December 17th. At T-minus 9 minutes, we're closing in on the final activities leading to launch. Let's go to Joshua Finch and Mike Curie in the control room to carry us through the final minutes of launch.
Thank you, Stephanie. The excitement is building. Everything is continuing in the countdown. We have heard that weather continues to be favorable. We're not expecting that to become an issue today. Josh?
And so we can cover some of the milestones that have already been covered during today's launch countdown. Launch Director John Meritor has verified the launch and first stage landing danger areas are cleared of personnel. The range coordinator has verified the eastern range is go for launch and landing. That happened at T-minus 38. The Dragon controller has verified the Dragon launch terminal count auto sequence has started. Loading of RP-1 fuel began on both stages of the Falcon 9 as planned, and liquid oxygen began flowing into both rocket stages at T-minus 35 minutes.
After launch today, Falcon 9's 2 stages will propel Dragon to a speed of 17,500 miles an hour in just about 9 minutes, which starts a journey that will culminate in a rendezvous with the International Space Station on Sunday. While in the vicinity of the station, the astronauts aboard will be in direct communication with the Dragon, monitoring the spacecraft and issuing spacecraft commands. After completing checkout procedures, Dragon will receive approval to begin gradually approaching the space station from the radial direction. Expedition 54 flight engineers Mark Vandehey and Joe Acaba of NASA will supervise the operation as the Canada 2 robotic arm moves in for Dragon's capture. And after capture, ground commands will be sent from Mission Control in Houston for the station's arm to rotate and install it on the bottom of the station's Harmony module.
The Dragon spacecraft will spend approximately 1 month attached to the space station. Unberthing and release of the Dragon from the space station is scheduled in mid-January. After 5 hours after Dragon leaves the station, it will conduct its deorbit burn, which lasts up to 10 minutes. It takes about 30 minutes for Dragon to re-enter the Earth's atmosphere and splash down in the Pacific Ocean off the coast of Baja, California.
Several folks are in control of launch today. As Josh mentioned, launch director is John Murator. Chief engineer Bala Ramamurthy. Vehicle controller is Frank Messina. Range coordinator is Mike Taylor. And again, our launch weather officer is Lieutenant David Myers.
At T-minus 7 minutes, the Falcon 9 Merlin engines were chilled in preparation for the super cold liquid oxygen and RP-1 propellants to flow through at liftoff. And the Dragon spacecraft went to internal power.
We're at T-minus 6 minutes, 34 seconds and counting. Coming up at T-minus 5 minutes, the TTEB engine ignition system will be pressurized. The Falcon 9 uses triethyl aluminum triethylborane, or TTEB, to ignite the 9 Merlin engines. TTEB is a pyrophoric, igniting spontaneously on contact with air, as opposed to some other engines that use electric spark ignition rather than this chemical starter.
At T-minus 5 minutes, the launch team performs communications checks with the Eastern Range.
At T-minus 4 minutes, 30 seconds, the strong back, which stands side by side, with the Falcon 9 to provide power and connections for RP-1, liquid oxygen, and helium will retract to the launch position of 88.3 degrees.
Within the last 3 minutes of the countdown, Stage 1 and Stage 2 liquid oxygen loading will be complete to flight levels.
At T-minus 2 minutes 55 seconds, the Falcon 9 Stage 2 thrust vector control actuators will move the second stage Merlin vacuum engine to verify its ability to control the spacecraft in flight.
About 2 minutes 45 seconds before launch, the strongback will reach its launch position, canted away from the rocket at an angle of 88.3 degrees.
Then at T-minus 2 minutes, the Air Force Range Control Officer will confirm the physical safety of the launch and landing areas and the eastern range, and the Falcon 9 will be verified to be on internal power.
At T-minus 1 minute 5 seconds, the autonomous flight termination system is verified to be ready for launch.
1 minute before launch, the flight computer begins final pre-launch checks. Propellant tanks are pressurized to flight pressure, and both the Dragon spacecraft and Falcon 9 rocket are configured to launch startup mode.
After polling Mission Control in Houston, Texas, and the launch team at SpaceX Mission Control in Hawthorne, California, Launch Director John Meritor will give a final go for launch at T-minus 45 seconds.
The terminal count will begin at T-minus 30 seconds.
18 seconds before liftoff, the launch pad's water deluge system, dubbed Niagara, is activated. It suppresses acoustic waves that radiate from the engine plumes to counter the effect of vibration on the rocket. Rainbird's Fire-X and deluge system maximum flow is over 600,000 gallons per minute.
3 seconds before launch, the 9 Merlin engines of the first stage are commanded to ignite using TTEB.
And at T-minus 0, the rocket computer commands the launch mount to release the vehicle for flight, and Falcon 9 lifts off, putting out over 1.7 million pounds of thrust, more than 5 747 jets at full power.
We're just under 4 minutes away from launch, and from now until liftoff, we will be monitoring the countdown net, the primary circuit used by the SpaceX launch team during the terminal count. Again, weather remains go. All the milestones have been occurring as expected. Next major milestone at T-minus 2 minutes 55 seconds will be the thrust vector control checkout that we were talking about. The Falcon 9 rocket stands atop its launch pad at Space Launch Complex 40 on Cape Canaveral Air Force Station, ready to make its first flight of the year. Gaseous oxygen is venting from both the first and second stages of the Falcon 9 rocket. T-minus 3 minutes and counting.
Stage 1 LOX load closed out.
First stage of the Falcon 9 rocket liquid oxygen system loading has closed out. Again, as Josh mentioned, RP-1 fuel is aboard both the first and second stages. The oxidizer aboard both stages is liquid oxygen.
Vehicles transitioning to internal power. Stage 2 LOX load closed out.
T-minus 2 minutes and counting. Stage 2 LOX closeout has occurred. The autonomous flight termination system will be verified ready for launch at T-minus 1 minute 5 seconds. Everything proceeding toward our liftoff at 10:36 a.m. Eastern Time.
AFTS is ready for launch.
And the autonomous flight termination system is ready for launch.
F9 is in startup.
Falcon 9 rocket is in startup mode.
LD is go for launch.
Launch Director John Murator gives his final go for launch. T-minus 48 seconds and counting. Terminal count begins in 5 seconds. The pad water deluge system will be activated at T-minus 18 seconds.
30 seconds and counting.
The main engine controller will command the engine sequence start 3 seconds away from liftoff. T-minus 20 seconds.
Stage 1 pressing for flight. T-minus 15. Minus 10,
9, 8, 7, 6, 5, 4, 3, 2, 1. And the liftoff of the Falcon 9 rocket and Dragon spacecraft, filled with science and supplies for humanity's research outpost in low Earth orbit, the International Space Station.
SpaceX Ascent commentary will be performed by several people. The propulsion engineer calls out propulsion events. The avionics engineer calls out avionics health and Dragon separation. The range coordinator calls out Air Force satellite control network acquisition and loss of signal. And the ground station specialist calls out the SpaceX antenna acquisition and loss of signal.
At 1 minute 5 seconds after liftoff, Falcon 9 reaches transonic speed. The vehicle will pass through an area of maximum dynamic pressure, known as max Q, at 1 minute 18 seconds after liftoff. This is the point where mechanical stress on the rocket reaches its peak because of the rocket's velocity and resistance created by Earth's atmosphere.
Around 2 minutes 24 seconds into the flight, the 9 Merlin engines will sequentially shut down, and you'll hear the call Miko, which is main engine cutoff. This first stage will perform a boost back burn about 15 seconds later, heading back to nearby Cape Canaveral Air Force Station Landing Zone 1. We'll show you the landing on NASA TV about 8 minutes after launch, accompanied by the sonic boom just before landing.
MVAC engine chill has started.
One minute 50 seconds into the flight of Falcon, carrying Dragon toward the International Space Station. Standing by for main engine cutoff.
We have Miko.
And we have Miko, main engine cutoff. All 9 Falcon 9 engines have shut down as planned.
And the first and second stages have separated as planned.
7 seconds after separation, the second stage's single Merlin vacuum engine ignites to begin a 6.5 minute burn that brings Dragon into low Earth orbit. The engines produce 210,000 pounds of thrust. At 3 minutes 4 seconds into flight, Dragon's protective nose cone, which covers Dragon's berthing mechanism, will be jettisoned.
Three minutes 8 seconds into flight.
Boost back burn shut down.
And the first stage boost back burn has shut down as expected. Second stage carrying Dragon continues on its way toward the International Space Station. 4 minutes, 10 seconds after launch, the first stage apogee has been reached, its highest point of orbit. Everything continues normally with the second stage carrying Dragon. First stage entry burn is scheduled to begin 6 minutes, 23 seconds after launch, about 10:42 a.m.
Acquisition of signal Bermuda. New Hampshire, acquisition of signal.
The New Hampshire tracking site acquires the second stage in Dragon. Meanwhile, you're watching live coverage of the first stage of the Falcon heading back toward Cape Canaveral Air Force Station, landing zone 1. 5 minutes, 31 seconds after launch. About 30 seconds away from the first stage entry burn.
Stage 1 entry burn startup.
And stage 1 entry burn is underway. It's a burn of about 10 seconds.
Stage 1 entry burn shut down.
Falcon 9 first stage headed back toward Cape Canaveral Air Force Station, where it launched 6 minutes, 37 seconds ago.
Stage 2 performance nominal.
Everything going well with stage 2 carrying Dragon to the
Stage 1 AFTS has saved.
International Space Station.
Stage 1 is transonic.
Stage 1 is past the speed of sound. It's now subsonic.
Landing burn startup.
Landing burn underway. First stage landing legs will be deployed shortly. And a sonic boom passes across the Florida Space Coast as the Falcon 9 first stage makes a pinpoint landing back at landing zone 1 at Cape Canaveral Air Force Station.
LZ1, the F9 has landed. Landing operators proceed to procedure 11.100, section 3 on LZ1 net.
Meanwhile, in space, stage 2 of the Falcon 9 continues to carry the Dragon spacecraft. We're 8 minutes, 12 seconds after launch. Less than a minute away from second stage engine cutoff. That's scheduled for a mission lap time.
LDN countdown.
9 minutes, 5 seconds.
Copy.
.30 seconds away from second stage engine cutoff.
Second stage AFTS has saved.
.10 seconds away from second stage engine cutoff.
Miko.
And SECO is confirmed. In about a minute, at a mission elapsed time of 10 minutes, 5 seconds, Dragon will separate from Falcon 9's second stage, and seconds later, Dragon will reach its preliminary orbit.
Acquisition of signal in Newfoundland.
Standing by for spacecraft separation. And Dragon is making its way away from the Falcon 9 second stage with the Earth limb in the background, headed toward its destiny and a rendezvous with the International Space Station on Sunday.
At 12 minutes into flight, the Dragon will deploy its solar arrays, and then after that begin a carefully choreographed series of Draco thruster firings to reach the space station.
Looking at the second stage engine, which did its job. And now a live view of controllers at the SpaceX Mission Control Center in Hawthorne, California.
Less than a minute away from solar array deploy.
Dragon makes its way away from the second stage. First part of its mission underway.
Dragon's propulsion system has successfully primed and all thrusters report ready for firing.
Standing by for confirmation of solar array deploy.
Expected loss of signal Bermuda.
Expected loss of signal, New Hampshire.
Looking at live views from SpaceX Mission Control in Hawthorne, California, as a team that assisted in the launch today and is tracking the progress of Dragon.
And we have confirmation of the Dragon solar array deploy. And as Dragon unfurls its solar wings, the spacecraft continues its journey to the International Space Station.
Dragon will arrive at the station on Sunday, December 17th, and NASA television coverage will begin at 4:30 a.m. for an expected capture at about 6 a.m. Installation coverage will follow at 7:30 a.m.
So with the successful launch and deploy of Dragon and the solar arrays, we'll now go back to Stephanie Martin.
Thanks, guys. And this concludes our live coverage of the launch of Falcon 9 and Dragon for the SpaceX CRS-13 mission. For more information about the International Space Station, please visit www.nasa.gov/station. And for more information about this mission, please visit www.nasa.gov/SpaceX. And don't forget to tune in to our post-launch news conference on NASA television at noon Eastern. I'm Stephanie Martin. From the team here at Kennedy Space Center, we'd like to thank you for joining us. Have a great day, and we will leave you with replays of today's launch.
Nine, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of the Falcon 9 rocket and Dragon spacecraft filled with science and supplies for humanity's research outpost in low Earth orbit, the International Space Station.
SpaceX Ascent commentary will be... One minute, 50 seconds into the flight of Falcon, carrying Dragon toward the International Space Station. Standing by for main engine cutoff.
We have Miko.
And we have Miko, main engine cutoff. All 9 Falcon 9 engines have shut down as planned.
And the first and second stages have separated as planned.
7 seconds after separation, the second stage's single Merlin vacuum engine ignites to begin a 6.5-minute burn that brings Dragon into low Earth orbit. The engines produce 210,000 pounds of thrust.
That's 10,
9, 8, 7, 6, 5, 4, 3, 2, 1. And the liftoff of the Falcon 9 rocket and Dragon spacecraft filled with science and supplies for humanity's research outpost in low Earth orbit, the International Space Station.
SpaceX Ascent commentary will be performed by several people. The propulsion engineer calls out propulsion events. The avionics engineer calls out avionics health and Dragon separation. The range coordinator calls out Air Force satellite control network acquisition and loss of signal. And the ground station specialist calls out the SpaceX antenna acquisition and loss of signal.
At 1 minute 5 seconds after liftoff, Falcon 9 reaches transonic speed. The vehicle will pass through an area of maximum dynamic pressure, known as max Q, at 1 minute 18 seconds after liftoff. This is the point where mechanical stress on the rocket reaches its peak because of the rocket's velocity and resistance created by Earth's atmosphere.
Around 2 minutes 24 seconds into the flight, the 9 Merlin engines will sequentially shut down, and you'll hear the call Miko. which is main engine cutoff. This first stage will perform a boost back burn about 15 seconds later, heading back to nearby Cape Canaveral Air Force Station Landing Zone 1. We'll show you the landing on NASA TV about 8 minutes after launch, accompanied by the sonic boom just before landing.
Eight, 7, 6, 5, 4, 3, 2, 1. And liftoff of the Falcon 9 rocket and Dragon spacecraft, filled with science and supplies for humanity's research outpost in low Earth orbit, the International Space Station.
SpaceX Ascent commentary will be performed by several people. The propulsion engineer calls out propulsion events. The avionics engineer calls out avionics health and Dragon separation. The range coordinator calls out Air Force satellite control network acquisition and loss of signal. And the ground station specialist calls out the SpaceX antenna acquisition and loss of signal.
At 1 minute 5 seconds after liftoff, Falcon 9 reaches transonic speed. The vehicle will pass through an area of maximum dynamic pressure, known as max Q, at 1 minute 18 seconds after liftoff. This is the point where mechanical stress on the rocket reaches its peak because of the rocket's velocity and resistance created by Earth's atmosphere.
Around 2 minutes 24 seconds into the flight, the 9 Merlin engines will sequentially shut down, and you'll hear the call Miko.
Nine, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of the Falcon 9 rocket and Dragon spacecraft, filled with science and supplies for humanity's research outpost in low Earth orbit, the International Space Station.
SpaceX Ascent commentary will be performed by several people. The propulsion engineer calls out propulsion events. The avionics engineer calls out avionics health and Dragon separation. The range coordinator calls out Air Force satellite control network acquisition and loss of signal. And the ground station specialist calls out the SpaceX antenna acquisition and loss of signal.
At 1 minute 5 seconds after liftoff, Falcon 9 reaches transonic speed. The vehicle will pass through an area of maximum dynamic pressure, known as max Q, at 1 minute 18 seconds after liftoff. This is the point where mechanical stress on the rocket reaches its peak because of the rocket's velocity and resistance created by Earth's atmosphere.
Around 2 minutes 24 seconds into the flight, the 9 Merlin engines will sequentially shut down, and you'll hear the call Miko, which is main engine cutoff. This first stage will perform a boost back burn about 15 seconds later, heading back to nearby Cape Canaveral Air Force Station Landing Zone 1. We'll show you the landing on NASA TV about 8 minutes after launch, accompanied by the sonic boom just before landing. And a sonic boom passes across the Florida Space Coast as the Falcon 9 first stage Makes a pinpoint landing back at landing zone 1 at Cape Canaveral Air Force Station.
LZ-1, the F-9 has landed. Landing operators proceed to procedure 11.100, section 3 on LZ-1 net.
Meanwhile, in space, stage 2 of the Falcon 9 continues to carry the Dragon spacecraft. Passes across the Florida Space Coast as the Falcon 9 first stage makes a pinpoint landing back at landing zone 1 at Cape Canaveral Air Force Station.
LZ-1, the F-9 has landed. Landing operators proceed to procedure 11.100, section 3 on LZ-1 net.
Meanwhile, in space, stage 2 of the Falcon 9 continues to carry the Dragon spacecraft. Spacecraft separation. And Dragon is making its way away from the Falcon 9 second stage with the Earth limb in the background, headed toward its destiny and a rendezvous with the International Space Station on Sunday.